In this video, I will be teaching the step response of an LTI system. In fact, how to evaluate step response from impulse response. So I will write step response of LTI systems. Step response of LTI systems. Let us consider an LTI system having impulse response h of n, input x of n, output y of n. This is the LTI system. When input x of n equals u of n, output y of n will be called s of n. S of n is known as step response of the system. We want to evaluate step response of the system when h of n is known to us. That is the aim of this topic. For the LTI system, shown in figure 1, we can write s of n equals u of n convoluted with h of n. Because convolution is commutative, this can be written as h of n convoluted with u of n. Because of commutative property. This implies s of n equals summation k equals minus infinity to plus infinity h of k into u of n minus k. I will call this as equation 1. We know that u of n minus k is either 1 or 0. When it is 1, when n minus k is greater or equal to 0, or n greater or equal to k, or k less than or equal to n. When it is 0, when n minus k is less than 0 or k greater than n. This I will call equation number 2. We rewrite equation 1 as follows. S of n is equal to summation k equals minus infinity to n h of k into u of n minus k plus summation k equals n plus 1 to infinity h of k into u of n minus k. What I have done is summation from minus infinity to plus infinity are split into two summations. First summation runs from minus infinity to n. Second summation runs from n plus 1 to infinity, which I call as equation 3. Substituting equation 2 in equation 3, we get. Substitute, what happens? See, this summation is for k less than or equal to n. K less than or equal to n means k takes values from minus infinity to n. This summation is for k greater than n. That means k taking values from n plus 1 to infinity. When you substitute equation 2 in equation 1, what happens is this u of n minus k will be 1, this u of n minus k will be 0. So what we get? We get s of n equals summation k equals minus infinity to n on h of k. The above equation means step response of an LTI system, step response of an LTI system is the running sum of its impulse response. Running sum of its impulse response. Very important. Impulse response. Similarly, for a continuous time LTI system S of t equals integration with respect to tau from minus infinity to t on h of tau. This means for a continuous time LTI system, step response S of t is the running integral of its impulse response. I will write it down for you. The above equation means step response is the running integral of the impulse response of the system. Very, very important conclusion. Now, based on this theorem, I will do few problems. So, this d tau, please write. I forgot to write d tau. Include. Okay. Evaluate the step response of the LTI systems whose impulse responses are given. First problem, h of n equals half to the power n into u of n. So what I will do is solution, replace n by k. What is h of k? H of k is what? Half to the power k into u of k, which is nothing but half to the power k into 1 equal to half to the power k for k greater or equal to 0. Half to the power k into 0 equal to 0 for k less than 0. I am going to sketch it now. Y-axis is h of k. X-axis is k. When k is 0, what is the value? 1. When k is 1, what is the value? Half. When k is 2, what is the value? 1 by 4. When k is 3, what is the value? 1 by 8. 0, 1, 2, 3. It decays exponentially towards k equal to infinity. At k equal to -1, it is 0, -2, 0, -3, 0. Now I have to apply the formula. Recall, what is step response? Step response S of n equals summation k equals minus infinity to n on h of k. Depending on the value of n, the summation has to be performed. So what I will do now is, let us take for n less than 0, see first one, let us take n equal to -1 as an example. Then you sum all the values of h of k from minus infinity to minus 1. What will be the summation? 0. For any negative value of n, the summation will give 0 result because all the samples of h of k are 0 for negative values of n. So I am going to say for n less than 0, S of n equal to 0. I again repeat. Recall S of n equals summation k equals minus infinity to n on h of k. We have to take we have to take n less than 0, n greater or equal to 0 next. When n is less than 0, as a matter of example, let n be equal to minus 2. Then k equals minus infinity to minus 2 on h of k. Add all the samples of h of k from minus infinity to minus 2. Obviously the result is 0. In general, for n less than 0, the summation will give 0 result. Next, I will take n greater than 0. For example, when n is 2, what will be s of 2? Please see the board. S of 2 will be what? Add all the samples from minus infinity to 2. So what you get? 1 plus half plus 1 by 4. Isn't it? Don't write this in the examination. This is only for demonstration. What is S of 2? Add all the samples of h of k from minus infinity till 2. Now we'll generalize. For n greater or equal to 0, what will be S of n? S of n is what? Summation k equals minus infinity to n on h of k. This I will write as summation k equals minus infinity to n minus infinity to minus 1 on h of k plus k equal to 0 to n on h of k. The first summation will be 0 because if you add samples in this figure from minus infinity to minus 1, the summation has to give 0 result because all the samples are 0 from minus infinity to minus 1. Therefore, the summation will vanish. However, this summation will give a value summation k equal to 0 to n. What is h of k given in the problem? It is half to the power k. Now apply the formula. I will apply a formula. The formula is summation k is equal to 0 to n on a to the power k equals 1 minus a to the power n plus 1 by 1 minus a, provided a is not equal to 1. So here what is a? Here a is what? Half. Therefore, I will write what is s. Therefore, s of n equals 1 minus half to the power n plus 1 divided by 1 minus half. It's nothing but 2 into 1 minus half to the power n plus 1. This is for n greater or equal to 0. Summarizing, S of n equals 2 into 1 minus half to the power n plus 1 for n greater or equal to 0. 0 for n less than 0. This is how, given the impulse response of the system, it is possible to find step response by using this formula. I'll go to the next problem. Second one, h of n equal to delta of n minus delta of n minus 1. Solution. Replace n by k, that gives you h of k equals delta of k minus delta of k minus 1. So I will make a sketch of h of k now. X axis is k, y axis is h of k. When k equal to 0, you have a sample of amplitude equal to 1. At k equal to 1, you have a sample of amplitude equal to minus 1. Rest of the samples are all zeros. Only two non-zero samples are there of amplitude 1 at k equal to 0, amplitude minus 1 at k equal to 1. Now what is the formula? Recall S of n is step response. summation k equals minus infinity to n on h of k. Now I'll take the case for n less than 0. For example, take n equal to minus 2. If n is minus 2, what this means? It means add all the samples in this figure from minus infinity to minus 2. Obviously, the result is 0. In general, you take any negative value of n and perform the summation, the result is 0. For n less than 0, s of n equal to 0. Next, for n equal to 0, for n equal to 0, what is s of 0? S of 0 is what? Summation k equals minus infinity to 0 on h of k. What this means? Add all the samples in h of k from minus infinity to 0. Obviously, the result is 1. Third one, for n greater than or equal to 1. What is it? S of n equals, for n greater than or equal to 1. I'll write s of n. S of n equals summation k equals minus infinity to n h of k. Now n has a range greater than or equal to 1. When n equals 1, add all the samples from minus infinity till 1. What is the result? 1 minus 1 equal to 0. You take n equal to 2. Add all the samples in h of k from minus infinity to 2. The result is 0. Therefore, I put the condition n greater than or equal to 1. For n less than 0, s of n will have no samples. At n equal to 0, s of n has a unit sample. For n greater than or equal to 1, again s of n is 0. If you want to sketch the step response, it is like this. X-axis is n, y-axis is s of n. When for n less than 0, all the samples are 0. At n equal to 0, you have a sample whose value is 1. For n equal to 1, it is 0. N equal to 2, 0. N equal to 3, 0. That means S of n is what? S of n is delta of n. This is the analysis. So, if the step response, so what is important here is, if you know impulse response, step response can be found as running sum of the impulse response of the system. I will go to the next problem. H of n equals u of n. Solution. H of k is equal to u of k. U of k is 1 for k greater or equal to 0, 0 for k less than 0. I'll make a sketch of u of k. X-axis is k, y-axis is u of k. For all positive values of k, you have unit samples. For negative values of k, all the samples are 0. This is h of k. Sorry, u of k. In fact, u of k is nothing but h of k. I sketch h of k. What is the formula? Recall. Step response S of n equals summation k equals minus infinity to n on h of k. First, I will take the case for n less than 0. N less than 0, what will be S of n? Add all samples in this figure from minus infinity to any negative value of n, the result is 0. Second, I will take for n greater or equal to 0. N could be anything, n could be 2. Then what is the value of this summation? Value of the summation is what? Add all the samples, 1 plus 1 plus 1 means 3. Summation k equals minus infinity to n on h of k. Please tell me now, what is, if you add, what is h of k from minus infinity to n? H of k minus infinity to n is same as minus infinity to minus 1 on h of k plus summation k equal to 0 to infinity on h of k. Infinity to n, sorry. First summation is obviously 0. Why it is 0? Because add all samples from minus infinity to minus 1, the result is 0. The second summation, for the second summation, You have to add the samples of h of k for any positive value of n. All the samples in h of k equals what? 1. 1 if you add from 0 to n, what you get? You get n plus 1. So summarizing, we get S of n equals 0, S of n equals n plus 1 for n greater or equal to 0, 0 for n less than 0. For example, if you want to check what you have done is right or wrong, please see what is S of 2. What is S of 2? S of 2 is nothing but summation k equals minus infinity to 2 on h of k. This means add all the samples in h of k from minus infinity to 2. So what is the result? The result is 1 plus 1 plus 1 equal to 3. In this expression you put n equal to 2, you get 3. Like this, this n plus 1 case can be verified by taking a specific example n equal to 2. So again I stress the point, step response is nothing but running sum of impulse response for a discrete time LTI system. Next problem. h of t equals e to the power minus modulus of t. Solution. H of tau, this is now continuous time, h of tau equals e to the power minus modulus of tau. This is nothing but e to the power minus tau for tau greater than 0, e to the power plus tau for tau less than 0. These two statements have been represented by a single statement here. I am going to make a sketch of h of tau versus tau. X-axis is tau, y-axis is h of tau. For tau greater than 0, we have got an exponentially decaying signal e power minus tau. For tau less than 0, we have got a exponentially decaying exponential signal e to the power plus tau. At tau equal to 0, the value is 1. In e power minus tau, you put tau equal to 0, you get 1. In e power plus tau, you put tau equal to 0, still you get 1. This is the figure. Recall, step response S of t equals integration minus infinity to t h of tau d tau. For continuous time system, it is integration, not summation. Please keep in mind. First, I will take the case for t less than 0. For example, assume t to this point. T less than 0. That means you have to perform integration on this figure from minus infinity to t. T being negative. For t less than 0, S of t equals integration minus infinity to t h of tau d tau. When t is negative, which out of these two expressions, which one you have to use? E power tau. So you get integration from minus infinity to t e power tau d tau. Integrate this. You get e power tau from minus infinity to t. So you get e power t. This is for t less than 0. E power minus infinity is 0. Next I will take t to be positive. T to be positive. Second I will take the case t to be positive for t greater or equal to 0. What is S of t? Integration from minus infinity to t h of tau d tau. Now t is positive. That means you have to find the area under this curve from minus infinity to this t. That means you have to perform integration of e power tau from minus infinity to 0. You have to perform integration of e power minus tau from 0 to t. There will be two integrals involved. Equals integration minus infinity to 0 h of tau d tau plus integration from 0 to t h of tau d tau. That means integration from minus infinity to 0 e power tau d tau, integration from 0 to t e power minus tau d tau. Integrate this, you get e power tau between minus infinity and 0. This integrate, you get e power minus tau by minus 1 between 0 and t. If you put tau equal to 0, you get 1. E power minus infinity is 0. 1 minus of. Put the limits now. E power minus t. Tau replaced by t. E to the power 0 is 1. So this becomes now 1 plus 1 is 2. 2 minus e power minus t. Now I will summarize. Summarizing, we get S of t equals 2 minus e power minus t for t greater equal to 0, e power t for t less than 0. This is how step response is found by using this expression. Next one, fifth one. H of t is equal to u of t plus 1 minus u of t minus 1. Solution. Replace t by tau, that gives h of tau equals u of tau plus 1 minus of u of tau minus 1. I am going to sketch now h of tau. X-axis is tau, y-axis is h of tau. Critical points are tau plus 1 equal to 0 gives you tau equal to minus 1. Tau minus 1 equal to 0 gives you tau equal to 1. U of tau plus 1 starts at t equal to minus 1 with unit value. At tau equal to 1, the second function adds to first function a value equal to minus 1. To 1 if you add minus 1, you get 0. That means this rectangular pulse is defined by this equation. Now recall S of t equals integration minus infinity to t h of tau d tau. Now I will take the cases in this manner. I will take t here. For t less than minus 1, what will be S of t? S of t will be 0. Because if we integrate from this figure from minus infinity to t with t less than minus 1, obviously the result is 0. Next I will take t here. Second one, t for t between minus 1 and plus 1. That means we have to integrate now from minus infinity to t h of tau d tau. This I can write as integration from minus infinity to minus 1 h of tau d tau, integration from 0 to t h of tau d tau. This integration is obviously 0 because from minus infinity to minus 1 if you integrate this function, the result is 0. What is h of tau between 0? What is h of tau between minus 1 and t? Between minus 1 and t, h of tau is what? 1. So 1 if you integrate minus 1 to t, if you integrate 1, what you get? Tau between minus 1 to t. So you get what? T plus 1. Third case I will take, I will take t here. Now t is more than 1. For t greater than 1, S of t is equal to what? Here t less than minus 1. Here t between minus 1 and plus 1. Here this t is greater than 1. For t greater than 1, S of t is what? Integration from minus infinity to t h of tau d tau. This will be split in this manner. Minus infinity to minus 1 h of tau d tau. Then integration from minus 1 to plus 1 h of tau d tau. Integration from minus 1 to t h of tau d tau. Obviously the first integral is 0. For the second integral from minus 1 to plus 1, what is h of tau? It is 1. What is the area this is plus 1, sorry. What is the area from 1 to t of this figure? Again 0. So 1 if you integrate to get tau between minus 1 and plus 1, the result is 2. So you can summarize. Summarizing we get S of t equals 0 for t less than minus 1, t plus 1 for t lying between minus 1 and plus 1. For t greater than 1, it is 2. For t greater than 1, this is the answer. If somebody puts a question at t equal to minus 1, what is the value? See, S of minus 1 is 0 here. In this equation, put S t equal to minus 1, you get 0. Minus 1 plus 1 is 0. You put t equal to 1. What is S of 2? 2. From this expression, for t greater than 1 also, the value is 2. So what is important is, when these kinds of verifications are done, correct, you will get full credit. This is only for your inference, for verification. This is the end of the problems on this topic. Thank you.